My dear students, today I'm going to explain about buses in microprocessor and register organization. Buses in microprocessor. There are three types of buses in microprocessor. One is address bus, data bus, and control bus. Address bus. The address bus contains of 16, 20, 24, or 32 parallel lines. On these lines, the CPU sends the address of memory locations that are to be written or read from. The number of memory locations that the CPU can address is determine the number of address lines. Then it is directly address 2 power n memory locations. This is all about address bus. Next, when the CPU reads data from or returns data to a port, it sends the port address on the address bus. For example, CPU has 16 address lines, can address up to 2 power 16 memory locations, which is nearly equals to 64 KB. Got it? Next, data bus. It consists of 8, 16, 32 parallel signal lines. The data bus is bidirectional. This means the CPU can read data from memory or from a port on these lines, or it can be sent out of memory or to port on these lines. Control bus. The control bus consists of 4 to 10 parallel lines. The CPU send out signals on the control bus, enable the output of address memory device or port devices. Typical bus signals are memory read, memory write, IO read, IO write. These four signals comes under control of control bus. Topic 2, Register organization of 8085 microprocessor. So in 8085 microprocessor, registers can be classified as general purpose registers. First one, temporary registers. Third, special purpose register. And fourth, 16-bit registers. In general purpose registers, register BCDAHL are general purpose registers in 8085 microprocessor. All these general purpose registers are 8-bit wide. They are less important than the accumulator. They are used to store data temporarily during the execution of program. Next, temporary register. In there are two types of temporary register: temporary data register W and Z register. A temporary data register, the ALU has two inputs. One input is supplied by the accumulator and another from temporary data. The programmer cannot access temporary data register. However, it is internally used for execution of most of the arithmetic and logic instructions. Next, W and Z register. W and Z registers are temporary registers. These registers are used to hold 8 bit of data during the execution of some instructions. These registers are not available for the programmer since 8085 microprocessor architecture uses them internally. Next, special purpose registers, accumulator, flag registers, and instruction decoder or comes under special purpose registers. First one, accumulator. Register A is an 8-bit register used to perform arithmetic and logical IO and load store operation. Register A is quite often called as an accumulator. An accumulator is a register for short-term intermediate storage of arithmetic and logical data in a computer's CPU. In an arithmetic operation involves two operands, operand 1 and operand 2. One operand has to be in this register. So first register must be an accumulator, and the result of the arithmetic operation will be stored or accumulated in this register only. Similarly, logical operations involve two operands. One operand has to be in the accumulator, also some other operations like complement and decimal adjustment can be performed only on the accumulator. Next, flag register. So coming to flag register, it is a 8-bit register in which 5 of the bits carry significant information in the form of 5 flags. First one, sign flag, zero flag, auxiliary carry, carry, and finally parity. Coming to sign flag, after the execution of arithmetic or logical operation, if D7 of the result is 1, the sign flag is set. For example, 10010110 or 1110 plus 10011101. So this is an 8 bit and this is an another 8 bit. So 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 0 with a carry 1. So 1 plus 1 which will gives 1 with carry 1. So a carry is generated from D3 to D4 bit. Next, 1 plus 1 again 1 with carry 1, 0 plus 0 0, 0 plus 1 1. Next, 0 plus 0 is 0 and 1 plus 1 is 0 with a carry 1. This is the result of arithmetic operation. Now, coming to sign flag, after the execution of arithmetic or logical operation, D7 of the result is 1. So, here this is the result. If it is 1, the sign flag is in set condition. If it is not 1 or 0, it is reset condition or in clear state. Next, zero flag. The zero flag set if the result of the operation is ALU is 0. So if we get the result as all zeros, then zero flag is going to set. Accumulator register. Flag register. This flag is set if there is an overflow from D3 to D4. So previously we get three ones here. So 1 plus 1 plus 1 we get 1 with carry 1. So a carry is generated from D3 to D4 bit, which is nothing but an accumulator. Auxiliary carry is set. Parity flag. Parity is defined by the number of ones present in the accumulator. After arithmetic or logical operations, if the result has an even number of ones, even parity, the flag is set. If the parity is odd, the flag is reset. So, after performing the arithmetic operation, you have to count down the number of ones. So this is 1, 2, 3, 4, 5. So 5 is an odd number. So our parity is odd parity. Next, carry flag. This flag is set if there is an overflow from D7 to D8. So here, so 1 plus 1 we get 0 with the carry 1. So this is the D7th place and we get a carry. So this is called carry flag. So this is all about flag registers in 8085 microprocessor. Coming to instruction register. In typical processor operation, the processor first fetches the opcodes of instructions from memory, getting instructions from memory, getting instructions from memory to execute them. So that is, it places an address of the address bus and memory respond to the placing the data stored at the specified address on the data bus. The CPU stores these opcodes in the register called register instruction register. So all these instructions are placed at some place that is nothing but then instruction register. This opcode is further sent to the instruction decoder to select one of 257 alternatives. So simply instruction register can hold the instructions or store the instructions inside this register. And finally 16-bit registers. So we have two registers that occupy 16-bit byte. One is program counter and another one is stack pointer. Program counter. Program counter is a sequence of instruction. As mentioned earlier, microprocessor fetches these instructions from the memory and executes them. The program counter is a special purpose register at a given time. It stores the address of the next instruction to be executed. So it will store the or hold the next instruction to be executed. Next, program counter act as a pointer to the next instruction. However, processor increment program counter depending upon the nature of the instruction. If one byte instruction it increments the program byte to 1. For 2-byte instructions, it increments the program counter to 2. Or for 3 bytes, it increments the program counter by 3 such that the program counter always point to the address of the next instruction. Stack pointer. The stack is a reserved place or area of the memory in the RAM, nothing but random access memory, where temporary information may be stored. A 16-bit stack pointer is used to hold the address of the most recent entries. So this is nothing but the stack pointer. So here we have discussed about the internal structure of register organization. So briefly I'm explaining one more time. There are four types of registers. One is general purpose register. We have six registers named BC, DE, HL. Next, temporary registers. There are temporary data register, comma, W and Z registers comes under temporary register. Next, special purpose register. Special purpose register, accumulator, flags and instruction registers comes under special purpose registers. Finally, 16-bit registers are program counter and stack pointer. So thank you. This is for today's session. Thank you.